Hello.
Hey, I hear you.
Hey, how is it going?
Great.
Good. Have you guys been in meetings all day learning stuff?
Yeah, we just
Oh,
finished a presentation, and so we're just
okay.
having like a 20-minute break until 4:30.
Oh, okay. Wow, they have you going all day, huh?
Yep.
Jeez.
We also have a
Well,
lunch break though.
right. Well, am I the last one for today, I assume?
Yeah,
Alright. So everyone's gonna be pretty tired. Oh boy.
somewhat.
All right. Well, I'm about to throw a lot of information at people, so we'll see how this goes.
It'll be fine.
Uh,
We're used to
yeah.
it.
So, how's the RU been so far?
I think it's been pretty good.
Have you been learning quite a bit?
Yeah, so I did a core in the fall, like for AI Club.
Oh, really?
Yeah.
Oh, nice.
And that was like the only other experience I really had with machine learning. So,
Mhm. All right.
uh,
Well.
I've
Oh
learned a
yeah, I
lot.
remember. I talked to you about doing the RU, didn't I?
Oh yeah, that's right.
Yeah.
You
Yeah.
were
I was the core director. Yes.
Yeah, I probably wouldn't have even applied if it wasn't for like you had sent a message in the Discord. That was how I found out about it.
Well, I'm glad you're here then.
It was great.
Yeah.
Yeah.
Awesome. Kind of sucks it's online though, but I mean, it
Yeah,
is what it is, I
honestly, I
guess.
was kind of at first I was like, eh. But a lot of people's internships like ended up getting canceled and
Oh yeah.
whatnot. So
Pretty
I
much
mean,
everything got canceled.
I prefer it being online than nothing, you
Yeah, just not doing anything for 4 months.
know.
Yeah. Well, do you have experience with Linux?
Yeah, I have a bit.
Okay, cool.
I'm on Windows now, anyways, but
Alright.
I have some experience in Linux.
So you got everything set up with SSH into Newton.
Yeah,
Okay.
um, I I'm still not sure why it didn't like set my path for OpenSSL
Yeah.
automatically.
Hmm. Yeah. Uh, Windows is Windows. So
Yeah.
no one knows why anything happens. So yeah. Hey, Robert.
Hey,
I've heard you've been working everyone pretty hard with meetings.
trying to get my money's worth.
Oh, geez. Yeah. Yeah, I am. I guess I had it easy the first few weeks of the REU last semester because I was the one because I always left early for the things for most of the meetings.
Well, yeah, but you remember you guys started the week early.
Oh yeah, that's right too. That did help. And those were the good old days, huh?
Yeah.
um. All right. So we're gonna start right at 4:30 then.
Yeah.
All right. All right. Well, I think today will be okay because we'll have extra time if we go over. So which we might. I have a bit of information here, quite a bit. Um, could you approve the pull request on the repo you made, the VPN thing, to add my stuff? So I finished the tutorials and everything will be on there, like write-ups, markdown files. There's 2 pull requests. You can just click on the fix a few mistakes and just merge it, and then just do the same thing for the added CIL tutorial. And I'll get everything into this repo here.
All right, Brandon, that should be it.
Okay, great. Because then can use the system link. All right. So I'll post this link in here.
OneDrive is so crappy.
OneDrive, yeah. Well, it's Microsoft.
It's the worst, man.
Yeah, I use actually I used to use Google Drive, but I have like a personal like cloud server now I set up. So I use that to store and sync all my files.
Yeah.
Goo- Yeah. Because Google Drive is nice, but it doesn't really allow you to like sync files between computers like automatically. Because like I have like my phone, my laptop, and my main computer. Like if I make changes on files like on my main computer, they'll automatically sync to like my phone and my laptop. So I don't have to worry about like copying files over and stuff like that. So which was kind of hard to do with Google Drive, but I had something like that.
Let's see. This is so annoying. All right, who's in the meeting right now that I can ask this?
Pedro and White.
Pedro, you're a UCF student, right?
Yeah, I'm a UCF student.
Try accessing the link I just sent you. So go to the file, or it says REU project proposals.
Where'd you send it to me, on Slack?
Email.
Oh, email. Okay. You want me to open the file?
The attached project proposal presentation schedule.
Okay. Yeah, it just downloaded it when I clicked on it. But yeah, I can see it.
What's the extension? Is it a spreadsheet or a doc?
It's a spreadsheet. I have both a spreadsheet and a doc.
And when you just click the spreadsheet, not the download button, but you just click the whole file thing, the little
Yeah.
attachment, does it open in a new tab or what?
No, I just clicked it and it instantly downloaded it for me. Maybe I can right click it and open it in new tab. No, it just downloads for me.
There should be a drop down arrow if you hover.
Yeah. Yeah, like even when I click open in new tab, it just downloads it.
Ugh.
What are you trying to do?
I gotta hold on. Let me call Cherry real quick, okay?
Alright.
I wonder why it does that. I guess because it's an attachment. So.
Downloading. Well, it could just be your client. I mean, I don't know what he's expecting to happen there.
Well, because like since it's a live document, he wants it to be such that he can just edit it.
Oh, okay. So it's like because Microsoft has their own online editing thing like Google.
Yeah, so like
Okay.
like Robert even said like he'd prefer to be using Google Drive or Google Docs or whatever,
I mean,
but they have to use OneDrive.
yeah, I usually stay away from anything Microsoft made, except GitHub, but they didn't make it; they just own it now, so it's okay. But yeah, I don't. Microsoft makes me depressed. The only thing I have that's Microsoft is a Surface Pro because it's actually a good computer. One of the few things they made that's actually like decent. So
yeah,
but expensive as hell, but it's still good. But yeah, I don't use Microsoft pretty much at all anymore. I mean, my main operating system I use is Arch Linux, so
oh nice.
yeah. So, but I only use Windows just to play games because I don't feel like the hassle of setting up.
You have a dual boot on your machine?
Yeah. I fiddled around with so what's really cool is with virtualization technology you can actually run a virtual machine and pass through directly like a GPU for it to use it for like just like if you're like running it on bare metal, which is really cool. But I had some issues with it, so I never Never got it working properly, but you can do cool stuff like that. But yeah, I just have a dual boot. So I just booted up for video games and whatever I need to run that can't be run on Linux.
Yeah.
All right. I guess I'll share my screen here. Get ready. Oh, I can share a specific program. All right, let's just see how that goes. ZSH. Whoa. I don't like what's going on here. I really don't like this. Okay, chat. Why does the Zoom minion go away? Oh, this is stupid. Pause share. Can you guys see my? You can see my screen. Yeah. I don't know if this is working. Let's assume it is. Could you see my screen? Sharing it now.
I can.
Okay, great.
All right.
Guys,
I just realized I'm muted. Sorry.
just testing things out, make sure it's working. I don't know why Zoom closes itself out when I share my screen. I really don't like that, but whatever. So I gotta set this up here real quick. All right. And I see you're recording this already.
Yeah.
Okay, cool. What is? Oh God. All right. Can you see my mouse cursor?
Yeah.
Okay, cool. All right. Yes, my computer's called NSA agent. Don't say anything.
Bum ba da bum bum.
Yeah. All right. If for everybody here, you guys all have your SSH access to Newton set up and ready to go. No issues. So I can help you out now if needed.
Yeah, I'm good.
Okay.
Wait, what did you say? What did you say, Brandon? Sorry, one more time.
I was just making sure everybody has access to Newton and it's working for them.
I don't think everyone does. We're still missing people, so
Yeah.
go in the general and tell everybody to come.
Of the Slack.
Yeah.
Okay. All right. You want me to ping people or?
Yeah, that's good.
For those who are here now, click the link to open up the tutorial. I'm going to be going through this. This is kind of a write-up of basically everything I'm going to go over today. And if you can, like, I don't know if you have like multiple monitors or something, but if you can, you should, or maybe even on your phone, you can open up the, there's a link that says you should open up the cheat sheet now. You should have that open because I'll help you remember commands and stuff throughout the tutorial. It's like just a bunch of commands listed there for easy lookup.
Where is this link?
I posted it in the Zoom chat. If you just
I don't think you can see the Zoom chat if you join after you sent the message.
oh,
So.
wow, Zoom's some great software. All right, I'll send the link again.
Thank you.
Yeah. So that's the link to the write-up. So I'm pretty much just gonna go through this entire tutorial today. So if you want to refer back, you'll have the recording or this document as well. Everyone in here?
So if you look, Brendan, I have people put, so Christian, Daniel,
Oh, they have
Dan,
numbers.
Pedro.
Okay.
Yeah, put the numbers next to me, please.
They have numbers. Oh wow, this is
Absolutely.
everybody. I won't reference name, only number.
Exactly. Number 8. What's your answer?
Call me 11, Brandon.
Okay. Oh, are you top of the list today? 11. All right.
I'm like 11 from oh god, what's the show?
Stranger Things.
Yeah, exactly.
Oh, I've not had the luxury of watching that show, but I've been recommended it. So yeah, maybe I'll watch it. I'll post this link again just to make sure everybody. This is the link to our the tutorial I'm going to be following today. If you didn't catch it.
So we're missing number 6 and number 10.
Now 10's there. It's just he has an X.
No, that's not number 10. He's X.
Oh.
Spencer's guest of ours.
Oh, okay. Interesting.
You know, want to know something interesting, Brendan? You can,
What?
I can request remote control of your machine through Zoom.
Oh God.
Isn't that nuts?
Okay. This is. I'm glad once I'm done with Zoom, I always make sure to kill the process and make sure it's completely shut down. Oh God. Yeah, I've heard some very shady things about Zoom. I'm not.
Isn't that crazy?
Gonna,
I was
yeah,
really surprised when
Yeah.
when they told me about it.
Zoom
So-
started the coronavirus.
Yes, they did.
All right. So we're just waiting on one person.
2, but you know what? Let's go ahead and
Okay.
get started. Does anybody, actually, let's do this right now. Everybody look at the number after you and go ahead and memorize whoever that is. So, Wei, do you know who number 6 is? By chance? Arushi is missing, and Genebates. Those are the 2. So,
All right.
all right, well, let's go ahead, get started.
Okay. All right. Well, welcome everybody. So I posted a link. I'll just post it again to make sure everyone has it. So this link is to the Markdown file. It's just a write-up of everything I'm gonna be covering today. So if you can pull this up to have this have it up as to follow along with me. This is going to be an interactive tutorial, so everybody will log into Newton and we'll all go through this tutorial in Newton and use these commands and see how they work in real time. There's also a cheat sheet for Linux commands that's linked right at the top of the tutorial that says it's a hyperlink that says you should open this cheat sheet now. That has like a bunch of commands and stuff that I'll be covering today that all in just one like quick reference document. So you can have that up as well to help you memorize commands and stuff. I just wanted to say also that the tutorial I'll be giving today is by no means an exhaustive list or complete like tutorial for everything command line. There's a really good course from Code Academy that's also hyperlinked at the beginning of the tutorial that you could do for free that has a lot more in-depth explanation for a lot of the stuff I'm going to go over and some more examples and stuff. So if you're still having some trouble, I recommend going through that. It's a pretty quick course. You can do it in like 2 to 3 days, like just working on a few hours a day. So I highly recommend that one if you need some more help. But first, everybody, we're just gonna start out by logging into Newton. So we're just gonna pull up your PowerShell or terminal, depending on what operating system you're using, and we're just gonna SSH it in Newton by typing SSH Newton. And we should
So
be
guys,
live.
let me say this. You have to be interactive in this session in the sense that if you're not keeping up with Brandon, please say something and
Yes.
have him stop and
Yeah.
catch you up. Okay, so this is not just a a lecture. This is an interactive tutorial that he's giving. So if you're not on track with him, then make sure that you stop him, because
Right.
he is your last hope for connecting. Not really.
Oh, geez. Okay.
No
Put
pressure,
pressure
bro.
on. Okay.
No
Thanks.
pressure.
Thanks.
No
Thanks.
pressure, buddy. Okay.
Yeah. So during any point in the tutorial, feel free to stop me. The tutorial is only an hour and a half. We have allotted for, but we'll have time to go over. So it's okay if I take some more questions and stuff. So just feel free to stop me whenever.
I have a question.
Yeah. What's up?
It said the authenticity of host newton.ist.ucf.edu and some numbers can't be established.
VPN.
Yes, you need to be connected to VPN. So
I just connected to it. Maybe it didn't.
yeah, you could just try again. If you're still getting it, then but you're connected to the VPN, then.
Yeah, I'm still getting it. I'm pretty sure I can double check.
Your connection. Yeah, double check your connection to your VPN.
Yeah,
Make sure
it
everyone's.
says I'm connected.
You could try maybe opening up a new prompt and SSHing. Maybe I don't know if that would fix it or not, but maybe. If not, then I would suggest trying to disconnect and reconnect to the VPN
Okay.
because it may be connected, but it's not actually properly like connecting you through the VPN. So, also wanted to say too that when I'm talking during this tutorial, I'll be mentioning like command line and shell terminal and like bash, some different keywords there. For now, they pretty much all mean the same thing. Each one actually has a specific meaning to it, but we're just gonna say for now they're all pretty much mean the same thing. Like they all mean the command line that we're gonna be typing at. So just as a forewarning as we go into this. So if you can give me a little a check mark, like the little yes, to say that were able to SSH into Newton, so I can see who. And if you haven't, just click the little no, so I can make sure everybody's good to go. Okay, we got some people. Callie's having some issues. Robert, could you actually give me co-host so I can like clear the reactions and stuff? That'll help me because I can like clear the reactions and ask to make sure like everyone's following along. Yeah, cool. All right. All right. So it seems like most everyone's connected. So it's not working still, Callie?
Yeah, it's not working.
Are you on Windows?
Yes.
Oh boy. So you're using the Cisco AnyConnect. That's connecting successfully, but you're not able to SSH it.
Yeah.
Did you make sure you typed the when in your config file you had the correct host name? So newton.ist.
Why don't you share your screen and let's get you set up before we move any further?
Yeah, that's probably a good idea.
Okay.
I can help troubleshoot here. All right, so let's say everyone else. Daniel, are you able to connect? All right.
Yeah, I'm fine.
Oh no, this you're supposed to type yes. Yes. This is like asking you because this is your first time connecting. So it's asking you, we haven't connected to this host before. Like, do you want to connect? So if you just type yes and press enter, it'll connect you.
Okay, and the error is fine.
It's not an error. Pretty much what happens is when you connect to over SSH to a server for the first time, that will pop up saying you haven't connected to this server before. Are you sure you want to continue? Basically.
Okay, thank you.
Also, I saw that it didn't accept your key. You probably have your username. I don't know if you have your username selected, typed out correctly in your config file. I think it's supposed to be CRCV03. I'm not sure.
03?
I'm not sure. Your username should be in your key file, like in the name of your key file.
Mhm.
Oh, now it's. Oh, I think it stopped me sharing my screen.
Where would it have the username exactly?
So in your key file name, it should be like CRCVREU3
Yeah.
_1. Yeah, so CRCVREU3 is your username, that first part.
Okay, that's what I put. CRCV3.
Is it CRCV3 or CRCVREU3?
Oh yeah, CRCV. Oh, I might have left out the RU part.
Yeah, that's probably what it is. Yeah, because that's your username for your account, so that needs to be correct for it to know what key to authenticate with.
Okay.
Okay, so you're getting fixed. Daniel, are you able to connect?
Yeah, I can connect to Newton just fine.
Okay. Joe, are you good to go?
Yes.
Okay, great. And all right, so who else? Christian, are you good to go?
Yes.
Okay, awesome. All right, so I'll share my screen here.
And then what do I do for the password?
It shouldn't be asking you for a password. If it is, then
Oh.
there's something wrong with your config file. Could you open up your config file? You can share your screen again. I can help you out real quick.
Okay.
Do you know where the config file is on the .ssh?
I was opening it up.
Oh, okay, great. Let me make sure.
Here it is.
All right, so host Newton CRCV. So for the identity file, you can just put yeah, I could send it in chat. You just want to put SSH/ and then the key file name. So replace that C users and all that stuff with that.
Okay. I'm gonna stop sharing because I can't find the chat.
Okay.
Thank you.
Yeah. So just let me know when you're connected.
I think also, Robert can correct me if I'm wrong, but I think our usernames are CRCV REU.student, then your number. And then you just typed in CRCV REU, your number. That could also be causing a problem.
That is correct.
Yeah. Okay.
And let me ask you this, Brandon, on Windows machines, aren't the forward slashes backslashes?
Yes, but when OpenSSH actually resolves that, it'll like fix it to the correct path. It's really weird.
Oh, I see. Okay.
So yeah, so just doing that it'll work. Yeah, it's kind of weird on how it does it. I was confused too.
Wait, so what's the username? It's that .student?
So in your key file name, it should have the full thing. So it should be, what is it? CRCV REU.student3.
Okay.
Yeah.
Okay.
So yours should be .student3.
Yeah.
Thank you.
Yeah, no problem. Okay, let me do that. Bring up the chat. Oh, God, Zoom. There we go. All All right, that's one of the major hard parts. So I'm glad we're able to get everybody's working, especially on Windows and stuff. I was a little worried about that stuff working. So glad. So who here is actually on like Linux or Mac OS? Could be,
I'm
like, a
on
little-
Mac.
All right,
I'm on a Mac.
Me too.
a few people. All right, cool. So things might be a bit easier for you then.
Yeah, I think I might be the only one using Linux.
mm,
I think everyone else
That's
is Mac and Windows.
you have switched to the master race.
All thanks to you.
Yeah,
Seriously.
Christ, that whole fiasco. All right, so this Callie, are you good? Are you able to log in?
Yes, thank you.
Awesome. So everybody should have so when you log in, you'll get this little welcome message, and then you'll have like your username at EV-user1 is the name of the computer that you're currently connected to. This is your prompt, like your shell prompt, and this is where we're gonna be typing all of our commands. Welcome to the command line. So we're gonna start off very simply running our first command. So our first command we're gonna use is called echo. And echo, if we run it, all it does is just it prints whatever arguments, whatever like text we give it. So if we just type echo hello, it's just gonna print hello for us. This is kind of like the print function you use in various programming languages, and this is very and we'll see more use for this like when we do scripting and other things later on. Yeah, so congratulations, you all ran your, if this is your first time using the Linux command line, this is your first command. So this is where the fun begins. All right, so very simple. This is very simple. We just prints whatever you want. So also you'll see me use this a lot, and the command is called clear, and that just clears the screen. So if you have like text and stuff, you type clear, and it'll just clear everything, so you can have a fresh prompt here. So our first main topic is going to be file and folder commands. So folder navigation, creating files, removing files, creating directories. In this case, directories is another name for a folder. And we're going to go through all those type of commands. So first, very simply, we want to know where we are in our computer right now. So like what directory we're currently in. And the command to find that out is pwd. So that means print working directory. So all of your working directories, you start out when you log into Newton, you start out in your home directory. So your home directory is in /home / whatever your username is. So mine's B Silva, so that's mine. All yours will have like the CRCVREU student name. So, and this will be your login username, so it'll be different for every person. So this is where we're currently at in the system. But right now, we don't know what's actually in this folder, and we're just kind of just sitting in here, but we don't know what's going on. So let's figure out what's going on in a directory. So for all you guys, if you type ls, we use this to list the contents of directories. So I'll have some files. All of you guys will probably not have any files at all. And that's just because you're a fresh account, you haven't done anything yet. So you don't have any like folders or files. But what's interesting though, is that you actually do have files. So just like I'm sure you guys had to deal with in the setting up Newton, you had to deal with hidden files. So in Linux and most other operating systems, hidden files are prefaced by a dot. And if we want to see what hidden files are in our current directory, we can type, we can do ls tick a. So, and it's like a little -a. So, so the -a basically tells ls to list hidden files as well as regular files. And you'll see here like what this, and we're going to go over like what this -a means and things like that in a bit. So don't be confused by that right now. So now when you do tick A, you're going to see some files. You're going to have like a bash history, bash RC. You're going to have a .ssh folder. So you'll have this here. You'll have some other files as well. So just for testing, we're going to go over these commands in a second, but let's run, let's just create a directory real quick. So I'm going to clear this out. I'm going to use this command called mkdir. This is for, stands for make directory, and then we're going to give it a name. So what directory name we want to create. So I'm just going to create a directory called test. And we're going to use this directory for like all these testing files and stuff when we're using these commands. So when I did ls, I listed everything in the current directory. But what if I want to list stuff in another another directory? So let me do ls test. So as you can see here in the test directory I just created, there's no files obviously because we just created it. If I can ls like one of my other things, like my environments, you'll see there's some more directories within that one. So you can ls, so you don't so you can ls whatever directories you can see here and see what's inside them. So when I did ls-a for the hidden files, what this -a, and we'll use this terminology throughout this tutorial, is going to be called what's a flag. So it's pretty much like a flag, like telling the program I want to see this behavior. And every program is different. Every program has its own flags. But when I do tick A, I'm telling the program I want you to list files in this current directory, but and also list hidden files. And last but not least, if you want to get like full information about what's going on in your current directory, you could do tick, and then we're going to provide 3 flags. We're going to provide A, S, and L, and that's going to make it list like in this. Instead of listing like this, kind of like from like left to right, it's going to list top down, and it's going to give different things like permissions, like creation date, and also show hidden files and all these things. You don't have to worry about like the permissions and stuff for now, but this is just a good way, like a different way to view files. Instead of listing them like this, you can list them like this and get all the information you can about them. All right, so that's just listing things. Everyone good so far? You're able to run the commands and see what's going on? Or you can just use like the little check marks, like the yes. That can be very quick. Okay, cool. And if you have an issue or something, you just do the no or just unmute your mic to talk. All right, cool. So that's just listing what's going on in different directories. We saw some things with pathing, like we saw when we did PWD, we saw this path here. When we did ls like test, you saw like I listed contents of this test folder here. But all this encompasses a path, and paths can be 2 different things. They can be absolute or they can be relative. So let's go over what an absolute path is. So a path, well, first of all, like a path on your machine first is just a path to some file, like how you navigate through your computer in order to reach some file or folder. So on Windows, and you would see like it would be like C users, like username, and .ssh like for the Linux tutorial. That's an absolute path. So that starts at the C drive and goes all the way through your computer to the specific folder or file you're mentioning. So when we do PWD, this gives us an absolute path to where we are currently at. So if I wanted to get the path of this test folder that we created, we're gonna want to cd into it. So what is cd? So cd stands for change directory, and what it does is it changes your current working directory. and I want you to pay attention to the term current working directory. That means the current directory we are in our current bash shell that we're in right now. So if I want to cd to this test folder, I can give it its absolute path. So its absolute path would be cd. We're going to go to b Silva, and inside b Silva, we know there's this will be your username. So replace this with your username, and that was in the pwe command. And then we know there's this test directory there, so we'll do test and then press enter. As you can see here, your bash prompt is going to change to tell you that you're in the test folder right now. So now when I do pwd, I'm currently working in this test folder inside my home folder for my account. So now that we're here, we can do the same thing. We do ls, as you can see here, doesn't show anything because we already know this directory was empty. We can run the other commands that we've used so far. So that is an absolute path. But the thing is that do you really want to have to type out home b Silva? What if I want to access like 10 directories deep? Like, you don't want to type out the whole thing every single time. And that's where relative path comes in. So relative paths are paths that are relative to your current working directory. So I'm currently in this test directory. Relative to this path, one directory up is my home folder. So if I go up one directory, I would be here in home b Silva. So that's relative to the test directory that I'm currently in. So, and the absolute path you'll see starts at the root of your drive. So root is this first /. That's kind of, so the root on like Linux systems is akin to like when you go in Windows onto the C drive and you see like double click on that and you see like program files and Windows and stuff, that's the root of your hard drive. That's like you can't go any higher folder than that. That's like where the starting position for all your files on your computer. So that's what I mean by the root. So now that we're in this test directory, we're going to want to go home. So we're going to go back to our home directory. So to do that in Linux systems is very easy. There's two ways. You could do in Linux systems, you can see here you have this little tilde. This tilde represents your home directory. So it's basically shorthand to say this user's home directory. So in my case, the tilde means home /home /b Silva. In your case, it would be /home / whatever your username is. And if we want to go home, we can just cd tilde. And now we are back in our home directory. You can also, as an example to show you, you don't even need to provide the tilde. If on the Linux system, you just type cd and press enter, it will always bring you back to your home directory, wherever that is. So that's very useful to quickly get back to your home directory. So now, say I want to cd into that test directory again, but I want to use relative paths. You actually just saw me do it when I showed you the cd command. So right now, I'm currently in my home directory, right? Now, if I'm in my home directory, I know that test is in here, and I can confirm that by doing ls. So now, with a relative path, I can simply just do cd test, and now I'm in test. And again, as you can see here, that's my absolute path to there. So there's one more thing to relative paths. So I talked about how you can cd home, and I've talked about also how that b Silva is like one directory up from test. Well, what if I just want to like cd into the directory above me without having to like figure out like where I am and cd like using the absolute path to cd to it? Well, what you'll see here, and what I'll show you, is when you did ls.a, you saw these two things always come up, dot and dot. So when you're in, no matter what folder you're in, this dot always refers to your current directory. So if I do ls dot, I'm listing the files in test. So dot always refers to whatever current working directory you are in. Dot refers to the directory above, one above your current directory. So if I had if my folder structure I have let me CD here. I'm gonna clear this out real quick. So I have home B Silva, and then in B Silva I have the test directory there. If I go, so the directory structure, I have home B Silva and then test. So B Silva is the parent, is what's called the parent directory of test. So there's like parent and then there's like children, or subdirectories are called. They're all terminology to pretty much mean the same thing. That test is inside the B Silva directory. So what I could do when I CD in the test, I want to go one up. So just to kind of show how this works, I'm going to make another directory in test called test2 just to show. So if I go into test2 real quick, I can see that now I'm 2 directories deep. I'm in test and then test2 from my home directory here. Now, if I want to just go to the directory above, I just do cd ... And it brings me to the, now I was in test2 and then now I'm back to test, as you can see here. And so that's all with relative pathing. So with relative pathing, dot will refer to the current working directory. 2 dots will refer to the directory above your current working directory, whatever the immediate directory above is. All right. So that was a lot about like relative pathing and stuff. Is there any questions about how relative paths or absolute paths work and how your system's laid out? Any questions at all? You can just unmute and ask. Nope. Everybody good then? Can you give me a little check mark so I know everyone's good? All right, great. Awesome. All right. So then let's move on to something that you're going to appreciate a lot. So as programmers, especially, we like saving time, right? We want to we're going to spend 10 hours to automate a 5-minute task. We want to save that time. So when you're working in the command line, it's no different. When you're working in the command line, there's a thing called bash completion. So what bash completion allows you to do is to press a hotkey to have your terminal automatically complete whatever command or file you're trying to type out to. So you don't have to type out the full thing yourself, and it's very useful for quickly completing commands. So let's go ahead and test it with cd back to our home directory and clear. Let's test it let's change directory into the test, but not have to type out the whole thing. So I'm going to do cd te, and then I'm going to press the tab key. As you can see here, when I press the tab key, it automatically completed the directory. And then I can press enter and cd. So let's try that again with test2. So I can do cd. I'm just gonna put the letter T, and that's it, and type tab, and boom, fills it in for me. I just saved 10 microseconds of my life, so it's pretty good. But this is especially useful when you're typing out really long commands and doing different things like that. So that's tab completion. And remember, you can use this for pretty much anything. So like, for example, like say I don't want to type the letter D. I just type C and I press tab. As you can see here, when I tried pressing tab, there's a lot of commands that start with C. So it's like, okay, do you want to display all these possibilities? So I'm going to press N, and so I don't see that. So you could theoretically complete that, although you would have to look at all those possibilities and stuff, and it's not fun. Let's try to make directory command. So I'm going to type mkd and then press tab. So as you can see here, when you press tab, the bash completion says, okay, well, it can be one of these possible commands to finish it, and then you pretty much have to keep typing and then press tab again to like kind of get the rest of the command. So with really short commands like cd and stuff, it's kind of hard to do because there's so many other possibilities. But when you have like specific programs and stuff, like say if I'm going to type Python, I could press tab here and it'll fill it in. So I can just do like pyt and press tab, and now it auto completes the Python. And you'll see this. You saw this Control C, which we're going to talk about in a second. So don't worry about that. If you just press enter, nothing will happen. So. Okay, so that's tab completion. I'm going to cd back to the home directory, clear again. So pretty simply, oh yeah, let me show you where, And I already showed you that. So yeah, so pretty simply, you can use tab to autocomplete directories. You can also use it to autocomplete commands and programs you're going to be using. You can even use it to auto. Some programs will allow you to use tab to autocomplete for subcommands within those programs, which we'll see a little bit later. It's pretty cool. So tab is very powerful. All right. So what you just saw there, the control C I did, that's what the little caret means. It means control. What that does is it pretty much kills whatever program or whatever you're typing currently in the command line. So say I type CD and I'm just typing a path documents, but I realize, wait, I don't have a documents folder, so it's the wrong name. I don't want to press enter because, I mean, you could press enter and you'll get this, but I don't really need to do that. What I can do is I'm like, oh, I made a mistake. I'm just going to control C, and control C will immediately kill whatever I was doing and give me a fresh bash prompt here. Also in Newton, it'll give you a sad face because the reason why it does that is when you control Cing a program, it's not like a nice like when you're on a computer, you press a little X on a program and it X's out nicely. Control C is like killing the program, like analogy like going to task manager and like ending the process and forcibly killing the program. That's what control C does. Luckily for the command line, most programs, if not all programs, are built to handle doing control C and getting interrupted like that. So you can use, like, you don't have to worry about like messing up a program or anything. You know, you can use control C. It'll be fine. Like, you're not going to break anything. So that's just using control C. So, and so say if you have a program running for a length of time, so you don't know this command, but I'm just going to show you something. So say if I have this program running and it's like printing out a bunch of stuff here, I can use control C and immediately stop it. It just kills the program. So yeah, that's just a quick hotkey, control C, pretty much universal for any command line, like even on Windows, Mac, Linux, if you're just using like local command line stuff, control C is pretty much universal to kill a program. You could think of C stands for cancel, so you're like canceling the program. All right. So there's some little tidbits there. Let's go into our next part. Our next big part with files is we're going to be creating, deleting, and copying and moving files, and also working with directories a bit more. So let's create a file. So in Linux, you can create empty files very easily with a command called touch. And touch will pretty much just make a empty file for you with whatever name you give it. This is really useful for like laying out a project. Like if I'm laying out like a project on my computer, like a new programming project or something, I'll use touch to create a bunch of empty files to kind of get a general layout of how I want my program file structure to lay out. So when I'm working, I'm not doing it on the go. I can have it like all planned out, so it's much easier going into the program. So I'm gonna cd into my test directory here. So I just do it here. So we have like a nice clean directory to work in. And test only has the test2 directory, which doesn't have anything in it. So I'm going to hit clear and clear that out. So let's use touch to create a file. So I'm just going to call it file1.txt. So as you can see here, this when we do ls now we see the file. So we see file1.txt. If we do the ASL with the ls, we'll see that it has no data. This is a 0. This is like I think how many bytes. This is measured in bytes of how large a file is. You'll see it's 0 bytes. There's nothing. This file is completely empty. There's nothing in it, so it takes up no space because all it does is just create the file. So now that we have this file 1, this isn't mentioned in the tutorial, and I actually forgot to add this in the markdown. A very useful command in Linux is called file. So what file does, it tells you what a file type is of some file on your computer. So as you can clearly see, this is a .text file. But in reality, when the file might not actually be a .text, it could be a picture and like improperly renamed with the .text extension. So to actually get what the real file type is, we can do file and then the name. So we're going to type in, I'm going to use tab to autocomplete. So as you can see here, I typed in FI and then press tab to autocomplete that. And it tells me it's empty. So this isn't even a text file. This is just completely empty, as you can see here. There's just nothing here yet, and we would fill it in later. And if I do file on a directory like test2, this tells me it's a directory. So if you have like, pictures, videos, any type of file, zip files, and you do file and whatever the file name, it'll tell you what type of file it is. So very useful for making sure files are what they say they are, basically. All right. So let's remove a file. So remove uses a very simple command, rm stands for remove. So we're going to do rm and let's annihilate file1.txt. And if we do ls, we can see it is gone. Now, important to note, this is not like right-clicking on a file and clicking like move to trash bin or delete like on most operating systems, because that won't actually delete the file and move it to some like trash bin. So, but the file's still there. When you use the remove command in from the command line here, it deletes the file permanently. Like when you do shift delete on Windows to delete a file permanently, it completely clears the file. You cannot get it back through easy means. You would have to like use like special software or forensic tools to actually be able to recover whatever file you deleted. So this deletes the file. So be careful when using it. Use it with great caution. Make sure you get your file names and whatever you want to delete correctly. So now, what if I want to remove a directory? So we're going to use another flag for the remove command. The remove command has a tick R, and I call the dashes, I call them ticks. So this mean the same thing. So you're going to use a tick R. So what tick R stands for recursive. So that means it's going to because if you try to delete a full or directory right now, because we have the test2 directory, and if you don't have it, remember we used to make directory command to create it. So I'll make another one real quick. Test3. So you can see we have two directories, two test directories. If I try to remove test2, it's going to be like, hey, you can't do that. This is a directory. Remove will only work with files, not directories, unless you use the tick R tag, or the flag, I mean. So if I do tick R and then test2, now the directory is deleted here. You can see test2 no longer exists. And this is recursive. So any file that was in test2 is also gone. Everything is gone below test2. So you may have seen the programming jokes or meme where you do like remove.rf/ to like basically remove every file in your computer. Yeah, don't do that, by the way. But you may have seen that, which we'll kind of go over that a bit in a sec here. So that's removing files and directories. I already went over, and so in the tutorial is a little bit out of order from how I did it, but here I have, we're in copying, moving files. I'm talking about making directories, so I already did that. So let's also talk about moving and copying. So I already have the directory test3 that I made here. Let's create another file. So it's called file1.txt. You can see there. I want to move this file around. I want this file to exist. I want to move it into test3. So I'm going to use test3, press enter. And now if I do ls, I can see the file's gone. But if I do ls test3, I can see file1.txt now resides in the directory test3. So mv stands for move, simply means move one thing to another. And the move works for directories too. So let me make another directory again. So I'll bring back to life, or I'll bring to life test1 here. I can move test3, the test3 directory, into the test1 directory. And when I ls, I can see test3 is gone. But when I do ls test1, I can see the test3 directory is in it. And if I do ls test1, test3, I can see file1.txt is safely inside there. So that's this move. You can also use the move to rename files. So I want to grab that file1.txt. So say I want to move this file1.txt. I want to move it into my current directory. Well, does anybody remember what I used to specify the current directory I'm in? can unmute and just to say it.
Dot.
Correct. Yes. So that would be the dot. So if I want to move it in my current directory, I want to move test1, test3, file1.txt. I want to move it to my current directory, current working directory. And I would do ls and file1.txt is back here. So let me go ahead and clear all this out. So now that file1.txt is here, I want to rename this. So I want to move this to, rename it to cool file. So you simply, you say move, I want to move this file and I want to move it to a new name. So I'm going to call it coolfile.txt. And now it's been renamed. So it's the same file with the same content, just with a new name. Careful with the move command. With the move command, you need to get the file extension right. So say if this was a text file, I can actually move this file into, I'm going to call it, I'm going to pretend it's a JPEG file. So now when I ls, you can see it change color. It thinks it's a JPEG now. But actually, if you do pick .jpeg, it just tells you it's still an empty file. So you got to be careful. When you move, you also need to retain whatever file extension it has. So the operating system knows what type of file it is. So I can move this back to, let's call it file.txt. You can see it's there. By default, if there's no file extension, the Linux, the operating system will just assume it's just a plain text file. So you don't really need a .txt, but it's useful to make it very obvious that this is a text file. So, all right. Any questions so far? No. All right, cool. So, all right. So we have one more thing to do with what's doing the files. We can use the copy command. So copy CP, very easy. So it works pretty much exactly how the move command works with move one thing to another thing, except instead of moving it, we're going to copy it. So I want to copy file.txt into file2.txt. As you can see here, it copied whatever file, the contents of file.txt, and then created a new file with the same contents, but also a new name called file2.txt. And this is the same thing where, and this works the same way with like rig remove. You can't copy directory. So if I try to copy test1 into test2, it's like it'll say, oh, I omitted directory test1. And we're going to use that same flag, tick R, in order to copy the entire directory. And now we can see we have the directory test2. If we ls test2, we can see that test3 is still inside of it. So both in test1 and in test3, or sorry, both in test1 and test2, the folder test3 exists. So it was a copy there. Be careful when using the copy command. If you're copying like really large files, the copy command will give no progress indicator of where it's at. So you there's other programs that will command line programs that will give you a progress bar and also allow you to pause and resume copying. But copy does not allow you to do that. You either copy everything at once or you don't copy at all. So just be careful when you're using that if you're going to use it for like really large files. All right, and we went over make directory. And I just want to summarize here what's doing flags and commands and stuff. If I'm typing a command, so test1. So this is the program I'm using. You can see the highlighting, right? I think so. Like when I highlight.
Yeah.
Yeah.
Okay, good. So the remove is the command. This tick R is our flag. This test1 is our argument. So test1 is an argument, just like function arguments in programming. You know, it's the same thing. This is an argument that I'm passing to the remove command, and I'm also passing the flag tick R. So this is a flag, this is an argument, and this is our command. And be careful with the tick R flag, because again, if you don't want to accidentally remove like your entire home directory or something, which you can do accidentally, so you definitely don't want to do that. So just be very careful when you're using tick R. All right. All right, so that concludes the first part of just like file and folder manipulation and stuff. So is there any questions on anything we've covered so far? Feel free to ask now. We're gonna start on the next section. Give you a minute to let all that sink in. Let's think about what's going on. Let's see here. And we're gonna start with the next section, which would be ones with wildcards and globbing. And I'm trying to, Zoom's kind of messing up on me here. Okay, I think you guys
Brandon,
can also, yeah.
in the event that, because like, for example, on my end, Zoom has crashed several times when I was running an editor at the same time, PyCharm. So in the event something like that happens, feel free to restart your machine because I'm recording into the cloud. So
yeah, no, I no Zoom. It's just the windows that I have up. They kind of get stuck and they don't let me move them. And
okay.
Yeah. So I think we're good. Yeah. Yeah, I think the stream and everything's still working here so far. All right. So if there's no questions or anything, sorry, one sec. All right, so we can get into the next section. So next up, wildcards and globbing. So say we've learned how to like delete like single files and folders, but let's say I want to delete multiple files, multiple folders, or like only delete like JPEG files or text files or different things like that. It would be really tedious to have to delete each file individually in a directory. And that's where wildcards and globbing comes in. So let's, for example, I'm going to create a few more couple of more files here. Just some random files. So let's clear this out. So this is what my directory looks at. I have some text files, I have some JPEG files, and I got some directories. So if I'm looking here and I'm like, okay, I want to delete all JPEG files only from this directory, I can use what's called a wildcard, and a wildcard is this little star here. So what this star means to Linux, to the command line, it's saying match anything before and after. So when I do star, I'm saying I want to match everything, like everything I can find. So for example, if you do ls star, you could see it matches everything. And it also went one layer deep, so it also went into test 1 and saw that it had test 3 in it. So that means it's just going to find everything. Now, I want to use, so knowing that star means find everything before and after, we can use it to kind of hone in on what we want to select. So, for example, if I just want to delete JPEG files, I'm going to use remove star dot JPEG. And what's happening here is that I know all my JPEG files end in .jpeg or .jpg. So what the star is saying, match everything, basically match anything up until this point, and then but it must end with but when I add the .jpeg to the star, I'm saying only match if the file name ends in .jpeg. So if we go ahead and run this and we ls, we can see that every single one of our JPEG files is now gone and match everything up to. So the star would match everything in here, but then from that, the .jpeg says, okay, from all those matches, I just want to match the JPEG files or the files that end specifically in .jpeg, and it match those, and then removes all of those files. So we could do the same thing with directory. So for example, so say if I have, let's look in test 1. Let's just create a new directory real quick. So, all right. So we're gonna cd into test4, and I'm gonna touch a few more files here, just to show you. Now I'm gonna cd ... to go back to my current test directory. So what I just did was I created the directory test4, put 2 files into it, and then now I'm back to my test directory. And I'm going to clear this out. So if I ls test4, I can see there's 2 files in it. Let's say I want to delete all the files in a directory, but not the directory itself. So I can do remove test4 /*. So what this is saying is I want to remove anything that matches test4 and then /*. So it basically means match any file, any folder, basically anything in here. And when I run that and I ls test4 again, all the files are now gone from that folder. File and file2.txt are now gone. Doesn't matter if you had like JPEGs or .py files for Python or whatever you had in there would have just been deleted by that. But the directory itself, test4, still exists. I didn't remove the directory. Yeah, so, hope Zoom doesn't kill me because I accidentally opened up a program. All right, so now that we have that, and that's just the very basics of globbing. So say, and you can also put things before too. So say if I had, so I have file1, file2, file3.txt. What if I only wanted to delete, and let's touch another one that's called, I don't know. I'm just going to create another file called not a file. What if I just only want to delete files that start with file and end with .txt? So let's try that. Let's do remove. I want it to start with file. I want to match anything in between the word file and its extension .txt. So it's only going to match things that start with file and end in .txt. So the files that it should delete would be file2, file3, and file from here. So if I run this, as you can see here, it deleted these 3, but it did not touch not a file.txt since it didn't start with the word file. So this is safe. So, and this is even more careful to be careful with globs, because you can accidentally glob or use wildcard and match things you don't want to delete and end up removing a lot of files that you didn't mean to remove. So be very careful that you're typing out your names and stuff correctly when you're using wildcards. But yeah, that's the extent of wildcards. Give me a little check mark to make sure everyone's good, or if you have any questions, you can ask them now. All right. Are everyone else good? I want to try to get check marks for most people. Also, to make sure you guys are still awake. I know it's been a long day, and I'm just kind of talking at you here. All right. Very good. So let's go on to our next section here. So now that we know how to navigate, how to remove, how to do some simple file manipulation like copy, move, make directories, touch new files. Now we have, so as you can see here, we have quite a bit of files. We have some text files, we have some directories, and they all have different things. You know, they have more directories inside of them, but I want to be able to find a certain file, but I don't know where it is now. So there is no just search bar in the command line. You're gonna have to use a command in order to find different things. And it turns out the command for finding files is called find. So the command would be called find. And so the find command is going to use flags and arguments together. So before we just kind of saw flags and arguments as separate things, but now we're going to the way some other commands work and how find works is that we're going to provide a flag, and then right after the flag provide arguments to the flag. So they're not just gonna go in one order. They're gonna be out of order from what we've seen before. So let's see how the find command works. So we're gonna type find. The first argument to find is always what you wanna where you wanna start your search. So I want to start my search in my current directory. And now I'm trying to find some file. I want to specify the flag. So this flag is actually not just one letter. It's going to be tick name. And right after this flag, I want to specify the name of the file I want to find. So in this case, we'll very simply just try to find not a file.txt. And when we do that, we can see obviously that not a file is right here. So let me, I don't remember what's in these. So let me do test1. So let me create a file, test1, test3, oh, spelled that wrong, test3, and we'll call it this file.txt in there. So now I want to find, so starting from this directory, I want to find a file called file.txt. And then it pops out, it tells me, okay, so from my current working directory, if you go into test1, test3, file.txt is right there. So we're able to find the name of the file. And you can also use your wildcards here too. So, and this will find directories too. So if I do find test star, well, the past my procedures for expression. Wow. If I do find test for file.txt, let me create some more files here. Clear this out here. Nobody saw that error. All right, so let me touch, see where we're at again. Let me touch test2, and we'll do another file3.txt. And we'll touch in test4. We're going to put in file5.txt. Just put some random files. So now if I want to find from starting this current directory, I want to find every file that starts with the name file. And I can use the star to glob to basically say match anything with a file starting with file. As you can see here, it found file.txt here, here, and here. So it found multiple of those. So the find command is actually really powerful in that it's really useful for creating being able to like execute different programs on what it finds. So there's actually some flags and parameters you can provide where you can say, okay, find all these files and then execute this program on each of those files one at a time. And so you could do some cool one-liners, as they're called, it like one line to run a bunch of different commands at once using the find command. We're not going to, that's beyond the scope of this, but very simply, you can just use find to find files. There's also another command for finding files that's a bit easier than having to you make sure you format it properly with find and stuff like this. That's called locate. This isn't available on all systems, but on most Ubuntu and Debian-based systems, the locate command is built in. And locate works more like a search bar. So you don't need any flags or anything. You're just going to do locate and just whatever file you want. So I'm going to do file.txt. And as you can see here, it actually searched like the whole computer and found file.txt, and basically it works a bit different than the find command. It'll find if it doesn't find actual if it doesn't find what do you call it? If it can't find the exact file, it'll look for files that are similar to it. It's kind of interesting though that locate didn't find these files. So I don't know how it works on Newton, like if it's set up properly on Newton or not, but just so you know that not all systems have it, but locate is sometimes easier to use for finding those files. But that's the find command. So you're sitting here and you're thinking, well, I want to know more about the find command. You mentioned some cool things. I want to read about it. So pretty much every single command in Linux has what's called a manual page. And there's actually a command to view these manual pages. And what a manual page is basically everything about the program. So what it is, how it works, all the different flags and arguments you can have, the proper usage, and also have some examples. So let's learn more about the find command. So the command we use to access the manual pages is called man. And then let's learn more about the find. And here, as it brings up this whole text wall, that provides anything you want to know about the find command. So you can see a name, like basic usage, description of what it does, all the different options and their explanations. So to browse the man page you like to navigate, you want to use your arrow keys to go up and down. You can also use F and B to go to like basically go pages. So like all the way to the H here is like one page, and when I do F, it continues on to the next page. So you can quickly go through the document, and you can use B to go up, or you can use the arrow keys to go line by line like this. And then when you're done with looking at the manual, says it right down here, you can press H for help or Q to quit. So if I just press Q, now I quit. I'm gonna bring that up again. Also, if you have your mouse, you can use your scroll wheel as well to go line by line, so that's easier. So that might be easier on that. So yeah, and so this will explain literally everything you wanted to know about this. There's tons of information about how this command works and how this program can work. And then at the end, let me use the F key. See, they might have some examples. Yeah, they have a lot of this. There's a lot that goes into command. As you can see here, it has a ton of examples at the end on how you can use the command as well. So let me press Q, and we'll quit that. So this is very important because the man command is going to be your friend in learning all about the different things we use that we went over so far, and new programs that you find and you want to know how to work. So you can even do man CD. CD has a whole thing on it with a whole bunch of different flags. So CD actually has a ton of its own flags you can use too. So yeah, we can learn more about that. So that's pretty important to keep in mind, and that'll help you out a lot, especially starting out. All right. So now we've worked with like empty files and directories. So let's actually work with some content and see how we can actually manipulate data that's in files. So most of the stuff that we work with in the command line is going to be, when you're editing files and stuff, are going to be some type of text file. So, even though it has like a .py extension or other things like that, all of them to the operating system are just really seen as like text files. They're just a file with some text in it. So we're gonna learn a little bit more about how to actually manipulate these files and search the files for certain phrases and do a bunch of cool stuff with it. All right, so let's start out. We're gonna want to learn how to actually download a file, because right now we don't really have anything to work with, and we're not going to sit here and type up some random stuff. So let's actually grab a file from the internet. So there's two programs that allow you to do that. The first program is called curl. So curl allows you to basically make any type of HTTP request like you would in a web browser from the command line. So what I can do with the curl command, I'm going to copy this from the tutorial that I have. I'll paste this in the chat real quick, because we're going to copy this file here, which is what is this? This is James Joyce's Ulysses from Project Gutenberg. So this is just this like a random article. We're going to go ahead and download that using the curl command, and it's going to receive that file. And if we do ls, we can see that it's the file is there. And what the tick O flag does is allows us to say what file name we want to save it under. So go ahead and download that. You can also use wget. So wget so curl is kind of like a general program that can do a lot of things. Wget is a program like webget stands for, specifically made to download files from the internet. And we have the similar flag. This is actually tick capital O to reference what our output file to be. But we can also use this as well, and we'll also download the file. And also has like a nicer like project bar and stuff. So. But they pretty much both do the same exact thing. So now we have this file here. So let's see. Let's make sure this is actually a text file. Wonder why. Huh, it says it's gzip. I wonder if it actually is. They might have changed it since I had from me doing this tutorial. But let's see if it actually is gzip compressed data. Let's take a look. So if we want to access the what's inside this file, we're going to use a command called cat. So what cat does is basically print out whatever the contents of the file to standard out. And standard out is pretty much just the output to your console. So you may have heard of using like standard out and standard error and things like that in your programming to redirect output to different things. So you know like what's error and what's output. So let's cat this file. So as you can see here, it's a bunch of like nonsense. So it looks like this is a gzip file instead of a text file, as this website claims this to be. Because as you can see, the download specifically said .text, but when we did file, it said it was a gzip archive, which is kind of interesting. So I wonder if this will work. So we can decompress this real quick. May have to go download a different file. Wasn't expecting this. Interesting. All right, let me fix this real quick. See, sometimes errors always happen, unexpected things. You got to have the right file extension for it to work. So let me see if gzip will actually decompress this. Oh, it did. There we go. So that's probably what you should have seen. So I'll go over what I just did there. So this is actually really good practice. So the file you downloaded will be called ulysses.txt. So I'm gonna actually go through this again, and I'll go through this together. So sometimes stuff happens. You get files that are not. This is a perfect example of you getting files that are not what they say they are. So this page 4. So when we downloaded this file, we expected it to be a text file, as the link to the name implies, but it's actually a compressed file. So it's compressed using gzip, which is just like a compression thing. So in order to decompress it, we want to rename the file with the proper extension. So the proper extension for gzip files is .gz. And then we're going to use gzip to decompress it. So gzip is just a command line program to like compress and decompress files, kind of like zip is. It's just another protocol for compressing files. We don't have to worry too much about here. But you can use gzip, tick D for decompress, and then you can just use tab to autocomplete that name. And now the file is properly decompressed, and we actually have the book now. So is everybody good for doing that?
Mine says it's not in that format.
Did you rename the file properly?
Yes, I named it ulysses.gz.
And when you did the gzip.d, it didn't decompress?
No.
Has anybody else decompressed it properly?
I wasn't even able to download the file. It gave me a could not resolve host.
All right, well, looks like this file had some issues. That's not a problem. I already know where you can pull some example text files from. So I'll just post that link real quick. So it's kind of dumb that happened, but things on the internet change all the time. All right, so this will be good practice then. I'm gonna send this link in chat. Go ahead and download this file. So let's actually hope this works. If this doesn't work, I'm gonna be pretty sad. I don't know, maybe it's Newton? Able to access this through the internet, it should work. Maybe not. Been bamboozled. I'm trying downloading with curl. Yeah, can't even download this, huh?
Brandon, I would just like to point out here the potential security risk.
Of what, using curl?
No, of downloading files that aren't what they say they are. In particular, going to download a text file that's actually a gzip.
Yeah, that
Because then you want it. Yeah, so if you want to elaborate a little bit on that, because I mean, you may have downloaded the Ulysses file before, but if it was some place you're unfamiliar with, you could be extracting an executable to whatever.
Right. Well, yeah. So there is some security risk with that. Luckily, so with executing something, it by default when you download a file like that, Linux won't execute it unless you say it can be executable, which we actually talk about later.
Not everybody's on Linux though.
Yeah. So this is kind of like an overall, like from working from Newton, that would be what happened, but kind of an overall security thing when you download files are not what they say, or be careful, when you're opening them and stuff. Yeah, just like that, where just the other day I was, when I went just yesterday, I was able to do that just fine, and now it's for some reason not the correct file. Just trying to find some random file on the internet where we can just download the show. I'll have to update the tutorial, so let me just try this to make sure it actually works. Maybe it's just Newton. I don't know. Because now it's not even letting me grab these files here.
There's been server issues on campus all day, Brandon.
Oh.
So that could be related. I don't know.
Well, we might have to skip ahead in the tutorial and just copy that. All right, so we'll just do this. So what link did I just send last? I don't want to use that. I'm gonna try opening that link we had here real quick. I don't want to waste too much time trying to do this. So when you actually click the link, it brings you correctly to the text for the Ulysses. So I'm gonna send that link again. I just when it's downloading it doesn't seems to have a lot of issues. So we're not gonna worry. Actually, since it worked for me though, it's kind of interesting. So actually, I already have it here. So what you can do is, so let me just actually go through. Open up the link like in your web browser on your computer, and it's just like a text web page. Just Control A to like select all the text and copy it to your clipboard. And we're gonna skip ahead, and we're gonna use Nano to actually edit a file. So, which I'm gonna go over later. But Nano is a command line text editor, so we can edit files in the command line. So I'll just quickly go through this. Open up the text file, copy in your web browser, just Control A to copy all the text, or to select all the text, and then right click and copy. And then we'll open up a new, we'll run a nano ulysses.txt. So we're gonna open up a new text file. And in order to paste into a terminal, you can't just do Control V. You got to do Control Shift V. That's the keybind to paste into a terminal. Or you can just do right click and click paste. So when I do Control Shift V, might take a second. Hopefully it actually pastes. Or Newton's gonna prank me one more time. Might happen. Let's see. Yeah, that's kind of odd. It's not even letting me paste. Oh, there you go. You should be able to just Control Shift V and paste all this. Maybe there is something wrong with Newton. And it's having some issue. Here we go. All right, so I pasted some text into here. So just go ahead. You don't have to paste the whole thing, but just select something. If you can't paste the whole thing, like it's not letting you, just select something. Just select like half of it or whatever. Just paste it. Like this. And then to save, we're going to use the keyboard shortcuts. We're going to go Control X. We're going to press Y and then press Enter. And we're going to save the file. So I just want to make sure everybody gets to this point and has some file with some actual text in it so we could work with it. So is everybody good? Any issues? Copying the text in there and using Nano? Give me a little check mark.
Mine's not quite working, but I don't really know why.
What's going on?
So when I paste it, it just has like a blank screen.
Oh, that probably means it's not pasting the whole thing. So just select like some of it, like just select like just the very first like part of it, just some text,
Okay.
and then right click and copy. It might not be able to copy the whole thing. I don't know what's going on with Newton. It's just having some issues. So I promise this worked on my machine, right? Yeah, this as long as everybody just at least gets some file with some text in it, then we can work with. Doesn't really matter what the text is for this tutorial. So
Okay, I'm sorry. Can you go over what to do after you paste it into the terminal?
yeah, you're just gonna do control, use the hotkeys, Control X. You're gonna click Y, so the Y key, and then press Enter, and I'll save the file.
Great, thank you.
Yep. Okay. So everybody else good? All right. Well, sorry about that error, but I think it's had some good examples of some real world stuff there. What could happen? All right. So now that we actually have a proper file here, so I'll just remove the Ulysses. So you should have a ulysses.txt file. So now we can let's go over how we can actually figure out what's in the file and how we can parse the file for specific things. So if we just do so the cat command will print out contents of a file to the standard out. So if I cat this, I'm going to get a bunch of text here. So as you can see, I printed all of the text in the file just all at once. So this is not very useful if your file has a lot of data in it. So if we want to view a file in a much easier to read format, we're going to use a command called less. So what less does, it prints the contents of the file to standard out, but gives you, like in the man pages, allows you to use your arrow keys to go through the file and use the F and B keys, just like in the manual pages, to go up and down in pages, as you can see here. So I can very easily read through the file at my own pace. I don't have to scroll up through my terminal and try to find where I started the command and things like that. And then when you're done, you can press Q to quit, and it'll quit out of it. So a very easy text viewer. It's called less. So you can also you don't have you can also cat. You don't have to only be able to use it with text files. You can cat JSON files, like programming file, like .cpp for C++ source files, or .py for Python files. You can basically, if it's in some type of text format, you can use cat or less to view its contents. So it's not just for .txt file specifically. It can be used for any file. You can actually cat things that aren't files, and you'll get things like you saw, like that garbage. Like if I cat, so for example, I'm actually just gonna cat I'm just gonna cat like some program. So this is like a bin file, like a program file. As you can see here, you're gonna get like a bunch of garbage to the terminal with also some text inside of it. So you're like catting, and so you'll know it's not a text file if you get like a lot of weird characters and stuff like this, because this is like hexadecimal data and strings and stuff. So now let's talk all about searching for between files. So we're gonna use another command line program called Grep, and Grep allows us to search for stuff inside files. So I want to find. So the way it works, you want to do Grep, what you're looking for. So like the words you're looking for, and then what file. So I won't want to look for, and I'm going to use quotes to encompass this, because it's good when you, if you have like spaces, if you have like a space in what you're looking for or something like that, you want to enclose the whole thing in double quotes in order to tell Grep that this should be all one argument. Because your arguments are usually split up with spaces, but if one of your argument has spaces in it, you're going to want to surround it in quotes to make sure it's read as one argument and not two arguments. So I'm going to go ahead. I want to look for the word, I don't know, So an example, I have stately. I don't know if we'll actually see that word. So let's do grep stately and useless. So as you can see here, I get a sad face because I didn't find that word. So I'm just gonna grep the word. I'm sure the word Ulysses is in there. No, Ulysses is not in Ulysses. Kind of interesting. Because I only copied the first part. That would work for me. So okay. So I'm gonna grep the word love, and as you can see, I'm gonna get some stuff in the beginning. So as you can see here, highlighted in red is what it matched, and it showed all the lines that it matched. And there's a bunch of different flags for grep to do different things. So if I just wanna grep just to show me the count of how many matches is found, I can just do give it the tick C flag, and it'll tell me that I found seven occurrences of this word. And if we count up here, 1, 2, 3, 4, 5, 6, so they found 8. So I don't think it counted this one, just the words love itself. So sometimes it'll lie to you, but yeah, that'll give you the count of the number of occurrences, but just the occurrence of what you found. In this case, it found like love and beloved, so it didn't actually find the word love. So this is the count of just this word that it found. Or it can be whatever you want. I mean, you can just search for like a single character. So there's 260 occurrences of L in the text as well. So at least for me, it'll be a little bit different for you. So you might think you can use the wildcards in your searches. You can use wildcards for what files you want to specify, but I can't do something. I want to find everything that starts with love here. This does not work. This wildcard does not. It will look for the actual string, this version of the star. The only way to specify things like that is to use regex, and you guys have probably heard of it. Regex is kind of, well, it's fun to use, but it's pretty complicated. So grep will work with regex if you know how to use it, and to filter out matches and stuff like that. But we won't worry about that right now. But you just can't use like star as the wildcard for searching for actual text, just for like the file names and stuff. So I want to look for so again, if you want to work for like a word, so lovely. So I don't think that example is in here, sadly, in the text I have. But if I just want to search for beloved with a space, and I can't scroll back now because I cleared. So let me just search for love again, see what I have. So if I want to search for like lovely murmur, I can actually just do grep. I'm just going to paste this in. As you can see here, it found me the exact match with including the space, and that's because I put this in quotes here. And that's because I put this in quotes here. All right, so that's just grepping for a single file. Just looking through a file and just looking for different words and stuff in there. So now with this, I want to dive into what grep is going to be used a lot in for different things. It's called redirection. So as we've seen so far, that all the commands we use have printed out the standard, have used standard in for input and standard out for output, and also standard error if there's errors and stuff too, which you don't really see here. So what you can do is that instead of just printing stuff to the screen and to standard out, you can actually redirect output to something else. You can redirect it into other programs. You can redirect it into a file. You can do a lot of cool things with it. So let's run the this grep command again for love. So if we run this command, we'll get all of this output. But say I want to actually save this output to a file for later use. I can use this little less than, and so instead of printing the standard out, I want to redirect the output into a file. I'm going to use this little character here, the greater than. So you can think of it that I'm going to run this command. I'm going to run this this love, grep love, and Ulysses.txt. And now I want to redirect that output into a file called output.txt. Output.txt. So what the output.txt does is it's going to create a new file called output.txt and redirect all of this into there. So you could think of it as this arrow kind of like showing the direction. I'm taking this and I'm putting it into this file. So it's kind of, you can see it as like the direction that it's going to be going at. So, hang on, my little vacuum is going here. I don't know if you guys can hear it in the background, but let's turn it off. So this is the power of redirection here. So I'm going to press enter here. And as you can see here, nothing got printed to the standard output. But let's take a look at that output file. We can see everything that was here that we knew what the output was now redirected into this file. So now this file now contains this data here, this text data. So but one important caveat to remember is that this will overwrite the file. So say, for example, I want to grep something different. So I'll just grep like the letter, or I'll look for like the word genuine, since I already see that in that match. I'm going to do that. If I cat the output.txt again, you can see here that this file was completely overwritten with this new output. So obviously you may not want to do that all the time. You may just want to append a file. So instead of overwriting it, we just want to add the results of something else. So to append, we're going to use 2 of the arrows, the greater than sign. So let me run the command again. Instead of doing 1, I'm going to do 2, output.txt. So when I do this and I run the command, and we can look at the output of the file, we can see that this was what originally was in the file here, this line, and then it appended everything else from the new search. So all of this again. So all of this up here got appended again. So that's why you see this 2 of the same line, because this was what was in the file before. So the two greater than signs, or the 2 arrows, it means redirect standard out to a file appending to the contents of the file. While 1 arrow just means redirect the output into this file and just overwrite like whatever is there, whatever is currently there in that file with the new data. Or if it doesn't exist, create the file. So that's redirection. Any questions so far, or any issues or errors you may have ran into? Nope. Give me a little check mark, or yes, or whatever. Make sure everybody's still alive with us. Okay, awesome. Great, guys. All right. So now we're going to talk about pipes, and you can think of this as kind of like pipes in the real world, like a pipe. But in our command line, it's going to work a bit differently. So we know that standard outs use.
Brandon, let's go ahead and finish up piping, and then if you would give them something to kind of maybe prepare themselves for tomorrow, and then let's call it.
All right. Well, I have actually, I'm pretty much almost done. I'll be able to finish by 6:30.
Okay.
That's fine.
I'll
be able to finish everything, and I'll be able to give something for tomorrow too. So.
Okay. All right. That sounds good.
All right.
Thank you.
All right. So so for pipes, so when we pipe different things, we're gonna be able to pipe the output of one program and basically pass it along to some other program. So instead of redirecting standard out to like a file, we can redirect it into a pipe. And we can also, and then when we redirect data into a pipe, we can then specify like where we want the data to go after it leaves the pipe. So we're able to connect different programs together using pipes. And let's see a little bit of action. It's a little bit confusing at first. So say I want to print out. I'm going to print out the file Ulysses, but I'm going to pipe that into the grep program, and I want to look for the word love. So what this is doing is that I'm going to print everything in this text file to standard out, and I'm going to redirect standard out into the grep program. And when I run this, you can see I actually get the same output I got before. What happens is that first we print everything to standard out, but instead of seeing that, we pipe that into grep. And so what grep will do is you can pass it a file, or you can also pass it data from standard from a pipe to search data from that pipe as well. So all that data that was passed from standard out here is then ran through this program here to look for the word love, and we end up getting the same results. And what's cool is with pipes, we can also further, you can have unlimited pipes. You can't, so if we want to further look for within this text here, let's look for the word mystery. We want to grep mystery. And boom. So it searched this text for love, and from this text that it found love, it searched for the word mystery, and then that's our output. And you can just keep going forever you want. And then say I want to further append or redirect this to the output.txt file, and I want to overwrite it. So now I did that. I added that to the end. And we're going to cap that out, and we'll see that's the output. Now, you may have noticed something, what I did there is that you see how like I was able to instantly like get this command back instead of having to retype it. This is actually a shortcut in Bash. And what this shortcut is that if you simply press the up arrow, you can see all the commands you previously ran. So I can keep tapping up, and I can see like a history of all the commands I've written. And I can use the down arrow to go back down to see all the commands. So this is very easy. It's like, say, for example, you type a command and mess it up. You don't have to type the whole command again. You can simply press the up arrow, and then you can then go through with your cursor, with the arrow keys and stuff, and modify. Like, say if I want a different file, I can delete this and modify it like that. And because what I did here is that I ran this command, and then I pressed the up arrow, and then added the output at the end very quickly to very quickly do that instead of having to type all of this first. So you can also, and then you can just press the enter key once you find something. So I can hit this, and I'll run this command again. So you can also use the control and press R, and you can actually, and then you'll get this little reverse search prompt, and this will allow you to search the previous commands you've used. So I want to search for grep, and when I search for grep, it sees that I found this. Whoops. Let me clear this out. When you do control R, I search for grep, it found a command where I use grept. So you can very quickly, or say if I do the control R and I search for CD, it found the last time I used CD, which I did man CD. And you can use the right arrow to then get out of this reverse search prompt and get back to your bash prompt. So that saves a lot of time when you're doing that type of stuff. All right, so last two things, editing text files and basics of shell scripts. So editing text files, so by far there's a bunch of different text editors. So, and what I showed earlier when we had those issues, I showed Nano, which is by far the most widely used one. Second up will probably be Vim. There's some debate about which one's the best, but Nano is a very user-friendly one. And there's some more stuff in the write-up about Vim, and because that's a very popular one as well. So if I want to edit a file, let's edit a new file called test.txt. So this opens up a new file, and as you can see at the bottom here, it says new file at the bottom. And now you can type. It's just like a text editor. You can type whatever you want. Test file. You just type whatever you want into this text file. There's also on your cheat sheet, there's a bunch of shortcuts in Nano already on there about what you can do. You can do different things like justify, where is to search the file, previous page, next page, cut text. spell check and do different. So Nano actually has built-in spell check. So you can do all of that here. I won't go over each shortcut, but you can mess around. The little caret sign is the control key is what that means. So to save a file in Nano, you want to do Control X. So Control X is the exit. Command, and it's gonna say, okay, do you want to save this file? And you can do yes or no. So if you do yes, you want to save the file. No will destroy changes. So any changes you made would not be saved. So I do want to save the file, so I'm going to type Y. And then now it tells me the file name do I want to write. So it says it already has test.txt here to write. I can actually change this to a different file if I want to. So if I want to do test2.txt or something. But all you do once you're at that, you select what file you want to, what name you want to save it as, press enter. And now we can see that the file is created. And it has what I wrote in there, just some gibberish. So that's the basis of text editor. You can use Nano to edit any text file that you can any file that you can cat, you can use Nano to edit, basically. So it's a very useful text editor, which you'll be using a lot. Like say, for example, you need to make a quick fix in the code on Newton. You don't want to have to like make the code fix locally and then push it up and do all that. You can just go on Newton and just edit whatever programming file, use Nano, and quickly make the fix and run your program. All right, so I'm going to skip over the root section on here. You can read that. That's just kind of a tidbit. And finally, bash scripts. So this is going to be kind of more of just a little bit of me talking to you real quick. So bash, so we mentioned like bash and command line and stuff at the beginning, but like what really is it? So and like what is shell and things like that. So shell is actually the interpreter for command line instructions. So for those of you that are familiar with Python, or getting familiar with Python, Python uses an interpreter because Python is a scripting language. It's not you don't compile your Python code and then run the executable. You run the script using an interpreter, and it's the same way your command line instructions. Shell is your command line interpreter for all these instructions that we've been running so far. Bash is just a certain version of shell that has some extra features like the bash completion I mentioned, like using tab and different things like that are not built into the default shell. And also in the Code Academy thing I linked at the beginning, there's more into about shell scripts and stuff. We're only going to need to know the very basics of shell scripts for working tomorrow. So tomorrow we'll be doing all our Newton specific tutorial, which is actually already up. So if you want to read for it beforehand, before going in tomorrow, I recommend doing that. But we're just going to create very simply a simple script that we're going to run through the shell interpreter just to see how it works. So we're going to use Nano to edit the file to create our first script file. So we're just going to call it script.sh. So script files, they're extension for script shell scripts files, I should say. Shell script files extensions and then .sh. So we're going to open that up. So we got a new file here. So every shell script needs to start with this little, it's not a comment up here, basically an instruction telling what shell interpreter do we use to run this file. So when you run this file, it's going to look here and be like, okay, I should use bash to run the script file. That's what this is saying here. And bash is stored at bin bash for every system, every Unix system. So that's what this is telling here. It's telling you what to use. And you'll see that in other scripting languages like Python and Perl and stuff, you can actually put this at the top. And instead of using like Python or Perl to run the program, you can just run the program directly and your operating system will figure out what interpreter to use to run the code in this file. In this case, we're using bash. So we want to tell the OS that to use the bash shell interpreter. I'm going to go ahead and just go over a few things. So things, just like in Python, the pound sign is used to denote comments. So I'm a comment. So this is just not read by the interpreter. It's just skipped over as a comment. We can go ahead and use our echo command from before. So write a nice hello world program in shell. You can also Also, what's cool in the shell thing, every program that we've used so far in this tutorial, you can use in shell scripts. Your shell script is basically like running your commands like you do one by one when you're typing them out in the command line all at once in the script. So let's echo something like current working directory, and we'll run and then we'll simply type pwd, and I'll run the print working directory command. And there's also variables. So just very quickly, so just like in Python, you don't specify like what type of variable is. You just set it to what value you want. So I'm going to set this variable to hello, to the string hello, and then I can also echo the contents of this variable. So the only thing in Bash is when you access variables, you have to put the money sign in front of it to say you want to access the content of this variable. If you just put my var, it'll just be like the reference to it, I think it is. I'm not completely sure. I think it just won't work. But when you use the money sign my var, it's saying, okay, I want to access the contents that are stored in this variable called my var. Let's go ahead and save that. Control X, Y, enter. And now we have this saved and we have the script. So now let's run the script. So to run a script in your current directory, you got to use dot to specify the current directory, and /, and this is specifying you want to like run a program. And then we're going to do script.sh. And then this happens. Permission denied. That's kind of weird. So I mentioned this earlier. We created this script file, but we didn't tell the Linux operating system that this file is actually executable. So when we try to run it as an executable, it's like, sorry, you can't do that. So we need to, in order to run this as an executable, we have to mark it, tell the Linux operating system that yes, this file is actually executable. To do that, we use the chmod command. I don't want to go in depth on this right now. It's a little bit out of scope with like permissions and stuff, but you can use the chmod plus X. What this does is mark a file as executable, and that's what this means here. And then we're going to type in the file name, and you can use tab to autocomplete. Press enter, and then now if we run this again, boom. So you see, printed hello world, we printed current working directory, and then ran the pwd command and printed the output, and then we also outputted the variable. So I highly recommend messing around with this a bit. You're going to need to know a little bit more about scripts for tomorrow, but pretty much it's a very broad overview I just gave now. But just remember that this is like any other scripting language. You can use loops and if statements and a bunch of logic and do a lot of really cool things, and that are that you can like automate in your your operating system. So say if you always have to type a bunch of commands a lot every day, you can put that into a script and just run the script and make it easier. All right, so that's the end of the tutorial here. If you have any questions or I'll hang out here for a little bit. Thank you guys. I know it's been a long day. Sticking with me through all this. I hope this really helped you, give you a nice crash course into the Linux command line. But the one thing I wanted to say is practice makes perfect. A lot of this stuff is just comes from experience of just using the commands over and over again every day, just to know off the top of my head, okay, I know what this command does and how to use it and things like that. It really just comes from practice. So if you feel overwhelmed or you feel like this is a lot, don't worry. I mean, it's a steep learning curve to learn all the shortcuts and all the commands and things like that. But use the cheat sheet, practice, look through that Code Academy thing, the course, and I promise it'll start making sense really quickly as you use it throughout this REU and for your future endeavors. Yeah, so that's the end. So I'll hang out here if you have questions or just want to talk or whatever. I don't know what you guys have planned next.
So Brandon, did you kind of tell them where we're going to be tomorrow to get them set up and ready?
Oh, for tomorrow? So tomorrow, well, you don't need to do anything extra to set up for tomorrow. The tutorial, I already have what I'm going to go over is how to set up your Anaconda environments on Newton, how to transfer files to and from Newton, and also how to create and how to work with Newton's resource manager called Slurm to be able to submit, be able to run your programs on Newton with GPUs and lots of memory and CPUs and things like that. So everything I've taught today, not everything, but a lot of things that I taught today, we're going to be, going over. It's going to be more command line stuff for Newton tomorrow. So, but otherwise, we're at a good state now to go into the tutorial tomorrow for Newton. So.
Okay, sounds good. So does anybody have any questions? Speak now or hold your peace.
You can also ping me on Slack if you have issues or just need some help or have some questions. So I'm available to you. So I hope the tutorial was good too. This is my first time giving a tutorial like this, so I hope I did well. Yeah, if you have any questions, feel free to speak now.
And I just want to confirm that everybody has set up access to Newton.
Yeah, I think everybody gave me check marks at the beginning.
Okay, good.
Yeah.
All right, well, that sounds good. Well, thank you, Brandon. We'll see you tomorrow.
Yeah.
Thank
No
you so
problem.
much. It was very helpful.
Thank you.
Thanks.
Thanks.
No problem. And again, the file's up, so you can look through the tutorial. Pretty much everything I went over is in this write-up document as well. Did I hear a question? Don't know if I interrupted somebody. No?
Okay, so, all right.
All right. See you
Okay,
guys
Brandon,
tomorrow
well,
then.
Yeah, thank you very much.
Yeah, no problem.
Bye-bye.
Thanks. Bye.
Mhm.